Good morning, good afternoon, and good evening, everyone. Welcome to our third day from Math Camp. And today we're just going to look at something which is about symmetry and a popular question about a general, how do you feeding water to his horse? So basically, we will start from the symmetry first. What is symmetry? The symmetry means that oh, there's a point here. And then can you find a point on the other side? So when we fold this paper along this line, these 2 points can meet together. They can meet at one point. So how can we find a symmetry point for this point about this line? Basically, we just draw a perpendicular line from this point to this line. So here we draw a perpendicular line. So some of you might what is a perpendicular line means? Perpendicular means the angle here is just 90 degree. It's just a 90 degree. It's a right angle. And then we draw this perpendicular line. What should we do? We should extend this line until the upper part and lower part they have the same length. And then we will just find the symmetry point is here. So for the first question, basically, how do we just know? How do we know the symmetry shape or symmetry figure of each figure? We just try to find out. Where are those points. We'll just find out the symmetry point first. So in the beginning, we have symmetry points, so we draw a perpendicular line from this point to this line, and then we extend it until the length. The length is the same. So we find these 2 points, they are symmetry. And then, if we are going to find a line's symmetry shape about the line here, what can we do? We just check the 2 endpoints because we know that 2 points can help us fix a line. So we just check the 2 endpoints symmetry point and we can get it. And then here, we just got the 2 symmetry points here. And then we just connect these 2 points we can just get. And for a third one, for triangle, it's the same. We got 3 symmetry points of the 3 triangles vertex, and we connect them, we got a new shape here. And for the parallelogram, which is the same, we already found this point. Is on a line, so we don't do this. So we just check for other points. Here we just got a perpendicular line from up down here. And then we do the same thing. Here. We make sure the upper part and lower part have the same distance. And then we just connect them. We can just got this shape. We can just got this symmetric parallelogram. And for a last triangle, I believe this part is not difficult for all of you. So we just try to complete it here. And then we'll come to the last one. And now we'll connect these 3 points. And this is how we find the symmetry shape and why it will relate it to our second questions. So let's look at the scene of the second question first. For a second question, there is a general. When he wants to go back to his camp, he planned to go back to the camp directly, but his horse is too tired and thirsty. It needs to drink some water. So the general had to just bring his horse to the river and then go back to the camp. But as it's just in a war, so the general must do it as fast as possible. How can he find? How can he find the shortest path? So for this question, it's just like a story. But how can we just translate it? How can we just translate it in English? Oh, how can we just translate it in mathematical language? Here, we can just treat the general as and the camp as the points, and we will just let the river to become the line, and now we let the general to become point A and the camp to become point B. It just means we're going to find a point C. We are going to find a point C. We're going to find point C dot AC plus BC is the shortest one. So maybe I can give an example. I can give an example here. We start from here to here, and then here to here. This point, we can just let it become point C. So how can we find AC plus BC is the shortest? Although the point C I just draw here, it doesn't mean we need to go in this way. The point C is just moving along this line. And then let us think about it. When we are asked how to find the shortest distance between 2 points, we will think of what kind of knowledge point? We will directly think of the distance, the shortest path between the 2 points is just the line segment which connect them. If we can connect A, B, we can just go the shortest path. But here we got some coincidence. We got some accident here. Hey, we must go to the river first. But if we connect A and B here, if we connect the point A and point B here, it's not okay. It's not okay to pass through. It's not okay to pass through the line. So how can we make sure? How can we make sure the path between A and B pass through the river? We can just use the help. We can just use the help of the symmetry. Here, we just draw perpendicular line from the point A to the river. And then we extend it to make sure it has the same distance. So for example, this point is called A prime. This point is called A prime here. And then what if we connect? If we connect the A prime and point C, if we connect the A prime and point C, what will happen? A prime and point C. Is it the same? Is it the same as AC? It's totally same because A prime and A, they are symmetry. They are symmetry points. And point C is just on the line. So when we connect A and C, A prime and C, these two segments here, they are totally same. They are totally same. We find AC. We just find AC prime. AC equals A prime C. And then this question just become A prime C and BC. What is the shortest path here? What is the shortest path between A prime and the point B? The path it just looks like this part. You just look at this. We just go from A prime to the C and go from C to the B here. How can we make the shortest? We just need to make sure. A prime, C, and B. We just need to make sure A prime, C, and B, they are on the same line, so that it will just become the shortest path. And then where is a point C now? Where is point C now? We just see where is the intercept between the point A prime and point B. So here is a line A prime B, and here is a river. Here is a river. The intercept here is just an intercept. And what we find out, if this is point C, if this is point C here, and we just connect the A and C. A and C equals A prime and C, and A prime C plus CB is the shortest at this time, at this moment. So we find AC plus BC will be the shortest one. So here, although it provides us a story, but we need to be capable of translate them into a mathematical language. We turn the people, we turn the camp to the point, and we turn the river. We turn the river to a straight line. And then we just use symmetric thing. It helps us. It helps us to make those complex line into a straight line. And so this is how we find our answer. So that's it. Thank you. Thank you for participating in our first week for Math Camp. And for next week, looking forward to your good and better performance. Thank you so much and see you tomorrow.